Hello everyone. In earlier video we have seen example 4 how to write the loop equations. Now in example 3 we have seen how to write the loop equation. Now in example 4 also we will see how to write the loop equation so that the total concept of loop equations will be clear for you and you will be able to write the loop equations for any circuit diagram. Okay. Here the example 4 circuit diagram I have drawn in a paper, okay, so that it will be more easy for you to understand. Here before writing the loop equation we will understand actually the flow of current, that is the path of the current. How is the path of the current? Actually here in electrical circuit we can see the two cells are given, okay, and 3 resistors are given. Means in this electrical circuit total 5 electrical components are there. In this electrical circuit 5 electrical components are there. What are they? 2 are cells, okay, 3 are resistors, okay. Now we have to calculate the potential difference across these 5 electrical components. We have to calculate the potential difference across these 5 electrical components, okay. In earlier video we have seen only one resistor and one cell, okay. Now here 3 resistors and two cells are given, 3 resistors are given. Potential difference, this is a KVL law. KVL law, okay. KVL means Kirchhoff's voltage law. In Kirchhoff voltage law we have seen that we have to consider a loop, okay. In order to calculate the potential difference we have to consider a loop. Either the loop we can consider in a either clockwise direction or anti-clockwise direction. It depends on us, okay. Here what we will consider, first we will see how many loops we can form in this electrical circuit diagram, okay. See here we can take 3 loops here, okay. 3 loops we can consider total in this circuit diagram. First A, B, C, D, E, F. This is one loop, okay. Okay, and the other one is F, E, D, G, H, F. Again the second loop, okay. And the third one is A, C, G, H, again A. The starting point and the end point should be same. If the starting point and the same end point same only, I will consider it as a loop, okay. The starting and the end point should be the same, then it is considered as a loop, okay, or mesh also we can consider. Then here we can consider in anti-clockwise or clockwise direction. Suppose A, B, C, D, E, F, A, okay, this is clockwise direction. Now I will consider anti-clockwise direction. A, F, E, D, C, B, A, anti-clockwise direction, okay. In the same way also, suppose anti-clockwise F, H, G, D, E, F, anti-clockwise direction, okay. Now here we can form the loop on wherever we want. We can consider it, we can choose a point here and from there we can make a loop, okay. It's not necessary to start a loop from A only, we can start the loop from C also, we can start the loop from G also, but the starting and the end path should be the same one, okay. In your textbook it is taken as A, B, C, D, E, F, okay. A, B, C, D, E, F is given. Now how many we'll consider the first loop, okay. We'll consider first loop here, okay. In first loop A, B, C, D, E, F, this is the loop, okay. First loop we'll consider clockwise direction, okay. We'll consider clockwise direction. Now draw the clockwise direction path, circular loop path. So A to B, okay. A to B we are considering the path, okay. A to B, here one electrical here cell is there, so the path of the circular path is in this direction, okay. Only circular path I am taking, loop path, loop, okay. From here I am starting, so circular path means in this way, in the like this circular path, okay. Circular path I am considering here, okay. So here loop path, again here also clockwise, here the electrical component is not there. Again here I will consider the circular path, I will consider. Here one more path is there, here also I will consider circular path, okay. Again here nothing is there, okay. Again nothing means here I will come and I will stop here, okay. Here the circular path, okay. Now we'll draw the uh, current path. Okay, current path. Now see here, A to B. A to B we are considering clockwise direction. Here clockwise direction we are considering. Don't consider this one. Path direction current you consider. This is the path na. Path current direction means plus to minus. Plus to minus means high potential to low potential means is it decreasing or increasing? Decreasing. Decreasing means what we will write? Negative. Okay, here the negative. Okay, negative. Here now see. Here how is the path, how the current is flowing? Here negative. Here the negative. Here the negative is there. Always current flows from positive to negative means current is coming from this direction and reaching the here because positive to negative direction. So whatever that current direction will be in this, see, in this direction. Mean these two are opposite. If two are opposite direction, what will write? If two that is, this is the circular path direction, this is the current direction. If both are on the opposite side, what will write? Will write plus. Okay, plus will write. No? If both are opposite direction, plus direction. We have considered, we have discussed this in earlier video. If both there is circular path direction as well as a current direction, if it is a opposite direction, then we will consider as a plus. Means what will write here? Potential difference. Potential difference here. What will write here? I current potential difference is I. What is the current flowing here? How we will write potential difference? V is equal to I1 R1. I1 R1. Okay, I1 and R1 here. Okay, so here plus we have taken. Now we'll come to the this path. Here nothing is there. So in electrical component is not there. So no need of potential difference. Again I am coming this side. This side means what? How the current direction? See here, current is flowing in this direction and the resistor, that is circular path, we have taken this direction. So both are in same direction. If both are in same direction, what will take? If both are in same direction, we will consider it as a negative. Okay, if the circular path direction as well as the current direction, if they are in same direction, we will consider potential difference. Potential difference means what? V is equal to IR. V is equal to IR means in each and every electrical component we have to calculate the potential difference. Each and every electrical component. So here electrical component is resistor 2. Resistor 2. Resistor 2 means here 2 na R2 means R2 I will write. What is the current flowing here? I2. So I2. I2 and R2. I2 and R2. But as these both are in same direction, I will write here as a minus I2 R2. Okay, next I will come this side. Okay, one more electrical component. How the direction of flow current is just see here. Here minus. Okay, here minus is there. Here minus. But this is positive terminal. This is negative terminal. Current is coming from positive. This is positive terminal. Means positive terminal to negative terminal. Means current is flowing in which direction? Positive to negative direction. See here. Current from here, see here, the current here, from here it is coming to this one, I2. Okay, from here, this is the junction here. This is the junction here. Here the junction is there. Here junction is there. Okay, so from here it is coming to I2 here. So what is happening here? Here we have seen I2 R2. So here what is the current direction here? Here minus to plus means low potential to high potential. If low potential to high potential, what current is decreasing or increasing? Here increasing. Low potential to high potential means current is increasing. If current is increasing, this one will become plus V2. Okay, plus V2. Here as the current is flowing from higher potential to the lower potential, minus V1. Here current is flowing from negative terminal to positive terminal means low potential to high potential. So I am considering as a plus V2. Here V1 minus V1, here V2. Here what we will write here? Here I1 R2. I1 R2. Why? Because these both are in opposite direction. This is the current direction, this is the circular loop direction. Both are in opposite direction, plus we have to take. Okay. If both are in same direction, minus we have to take. Okay. Now we will write the potential difference of batteries, these two batteries and 2 resistors. What will write? Potential difference resistor 2, first we will write 2 batteries. Okay, what is there? Minus V1 here plus V2. Okay, this 2. Now 2 resistors we will write. Okay, resistors what we will write here? Plus I1 R1, this one I1 R1, this one minus I2 R2. If we combine these two, means if we loop means what? A combination of all the electrical components, means we have to write combining net charge. Net charge is minus V1. See, we will write in the circular form V1 plus V2 plus I1 R1 minus I2 here I2 R2. R2 means how much current? I2 R2. I2 R2 is equal to 0. Means net charge is equal to 0. Okay, this is the first loop we have considered. Second loop you can try by yourself. Okay, here first we need to understand the current, how the current is flowing. See here, the current here it's starting I1. Okay, here the positive direction, current is flowing in this direction. Okay, coming to here, till here it is coming. Again from here positive, negative, current, again one more current. 2 batteries means potential difference will be different now. Here potential difference will be different, here potential difference will be different, because here one battery is there, one battery. Means current from this potential difference will be different, current from this potential difference will be different. Means current from V1 means battery V1 we are getting I1 current from V2 potential difference V2 we are getting I2. Here I1 is coming, here I2 is coming. Here it is at the junction, they both are meeting, I1 current and I2 current, both they are meeting, they are coming down. Again what is happening here? I1 I2 both they are getting, they will meet here again they will flow like this, again it will come here, again it will move up. What happens here? What happened here? Here I2 current is there na? So I2 current will go this side, I1 current will go this side. Okay, means what is happening? At the junctions they are meeting here, at the junction they are meeting, again at the junction they are dividing into I2 and I1. At the junction they are meeting I1 I2, at the junction again they are distributing as I2 and I1. This is the direction of flow of current. In that we have to consider the loop 1. Okay, loop 1. Now we will consider the loop 2. Okay, we will consider the loop 2 will consider. Okay, same way we can write it. Okay, so we will consider loop. What's the loop here? F E D G H. This is the second loop. Okay, this is the second loop. Now tell me how the current direction will be. Now what we'll do first, we'll draw a circular path direction. Okay, what you do is you take a pencil in your exam and a pen, so that pencil pen, if you differentiate the circular path direction as well as the current direction, it will be easy for you. Okay, so circular path, how many components are there? First check in this look, how many electrical components are there? 1 2 3. Okay, only 3 components are there in the second loop. Okay, I am taking the clockwise direction, so this is clockwise, this is clockwise. Okay, again here the clockwise. Okay, that's it. Okay, again here current will come, again it will go to the here. Okay, now see here, don't get confused here. Now we'll see the how the flow of the current direction will be. Now see here this is a circular path direction. Okay, here how the current is flowing here, plus 2 minus means what is happening here? Current is increasing or decreasing? High potential to low potential means current is decreasing here. Here current is decreasing means what? V1 or V2? Here we will consider it as a V2 is given. So here current is decreasing or increasing? Tell me now. Here the current is decreasing. See, higher potential to lower potential. Higher potential means lower potential means what? Decreasing means here will become minus. Okay, so potential difference is minus V2 cell. Okay, across cell. Now we have to consider the current here. Okay, see the how the current is coming here. Here the direction of the current. This is the circular loop. The current is coming in this direction. Okay, current direction in this. So here this is here, this one, and this. How the opposite direction? If both are in opposite direction, what we'll write? We'll write plus or minus. What we'll write? Tell me. Here we'll write it as a plus. Okay, opposite direction means plus. We have considered here opposite direction. See here, opposite direction. Opposite direction means plus. We have write. So here also opposite direction. Opposite direction means what we'll write? Plus. Minus I to R2 means here resistor. This is the resistor one. I2 plus I2 R2. Okay, plus I2 and R2 we have to write here because loop, where the loop will start, there the loop has to end. Okay, here what we will write? Opposite direction, as the circular path is here and the current direction is here. Opposite direction means we have to write plus. I have written plus. Again I will come this side. Okay, what is there here? This path. This is the path. Okay, I will come this side. No component, so this side I will come. So what happens here? Here we can see circular path direction. This is a loop path. This is the loop path. Now we will see the direction of current. How is the direction of current? See here. See, this is the direction of current. Direction of current is in this direction. Again, what is happening here? Is it same direction or different direction here? Same or different direction? Again the opposite direction. This is the opposite direction. If opposite direction, what we have to take? Opposite direction is again plus we have to take. Okay, plus. But the current is what? The current flowing here? I1 plus I2. Here potential difference across the resistance R3, we have to consider V is equal to IR. Na? V is equal to IR, because here, but here current is what? I1 plus I2. I1 plus I2. So instead of I will write I1 plus I2 into R. But as the circular path loop direction as well as the current direction is the opposite, I will write here plus. Okay, plus I1 I2 into R3. Now combine all this one, that is we will write in the form of a equation, that is one cell, two resistors, one cell, two resistors. Now I will write in a form of a equation. What I will write? Minus V2 plus I2 R2 plus I1 plus I2 into R3 is equal to 0. Okay, two loops I have considered. The third loop also the same thing. The third loop we have to consider. Suppose in a circuit diagram also, I will show in textbook. Okay, actually in this two loop all the directions are marked. In textbooks it is not marked, so that it will be clear for you. Okay, so see here I am considering here that this loop, which one? A, B, C, D, A, B, C and G, H, A. Okay, this one we should not consider. The middle one again we should not consider. Already we have considered in second loop. Na? So this will not consider. A, B, C, G, H. Okay, this loop consider. Now tell me the path of this. I am taking the circular path. AB means circular path, that is a clockwise direction. Okay, clockwise direction, this is the path. How many electrical components are there? See here, 1, 2. Okay, 1, 2, here nothing, here 3. Okay, here nothing, means one cell, two resistor. One cell, two resistor, potential difference we have to calculate. We should not consider this one, middle one we should not consider. One cell is there, two resistors are there, means we have to calculate the potential difference of three electrical components. In three electrical components, two are resistors and one is the cell. Okay, now tell me the path. This is the circular path. Okay, like this it will come, and this one is this one. Okay, this is the clockwise direction. This is the clockwise direction. Now tell me the path of the current. Okay, direction of the current. See here we are taking clockwise direction, means plus to minus. Plus minus means what is happening? Potential decreasing or increasing? Decreasing. means minus, we have to write, means minus V1. Okay, now tell me the path. This is the negative terminal. Negative terminal means positive current will come from this direction and meet this one, because current always travels from the path of the current is from positive terminal to negative terminal. Means here negative terminal is there, means current is coming from the other side to meet the negative terminal, isn't it? So this is a positive terminal, means positive, higher potential to lower potential. Higher potential to lower potential means current is coming in this direction. If the directions are opposite, then what did I tell you? If the direction are opposite, then we'll write it as a plus. Direction is opposite, we'll write the plus. Then what is the potential difference? V is equal to IR. What is the I here? I is the I1 current. Okay, I1 current. What is the resistor? R1. Okay, so now finished here. Now again we'll come here. So what is the here? What is the potential difference across R3 resistance? The circular path is, that is the loop path is clockwise direction. This is the clockwise direction. How the current is flowing? See, the current is flowing in this direction. In this direction means path of the current is in this direction. Both are same side or opposite side? Opposite direction. Same direction or opposite direction? These two are in opposite direction. If two are in opposite direction, again we have to take the plus. Plus means what you will write? Current is I1 plus I2. Here the current is I1 plus I2 means what you will write? I1 plus I2 into R3. I1 plus I2 into R3. So combine all these values, add this net charge. If you want to find the net charge, net change in potential difference, if the net change in potential difference means V1, here what is the potential difference, here what is the potential difference. If we add all this one, we will get the net change in potential difference. The same thing is written here for you. Okay, see here V1, I1, R1, this one is the potential difference. Okay, I think here it is clear everything. Okay, we'll see this example. Okay, in this text only I will explain. Okay, see here. See here, we'll see this loop here, AC. Okay, AC. See here, we'll consider this loop for the loop AC DBA. AC DBA. Okay, we have started the starting point and the end point. Starting and the end point are same here. So what we are doing, we are considering the anti-clockwise direction. See here, anti-clockwise direction, not the clockwise direction. In this circuit diagram, we did not consider the clockwise direction, but we have considered the anti-clockwise direction. AC, AC, CD, okay, and DBA. Okay, now we'll start. I'll draw the anti-clockwise path. Okay, anti-clockwise, 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 again anti-clockwise. Okay, now we'll see the direction of the current. What is the direction of the current? Here nothing is there, no electrical component, so no need of direction of the current. Okay, no need of direction of current. Here what is the direction of the current? See here, the path you consider. Okay, don't consider this direction, don't consider this direction. We are considering the path, that is we are considering the loop path. Okay, we are considering the loop path we are considering. So loop path means see, positive to negative. If positive to negative means what? Potential difference is increasing or decreasing? Here potential difference is decreasing. Higher potential to lower potential. If higher potential to lower potential means lower means decreasing. So here what we will get? We will get the minus V2 here. Okay, next we will come to this. Okay, we are considering this is what? This is the loop path. Okay, loop path here, circular, anti-clockwise direction. What's the current here? Here minus is there. Minus is there means current may be coming from the other direction here. Means like this it is coming. Means current direction is a loop path is here and the current direction is this one. Means here opposite direction. If opposite direction plus I2, current is I2 here, resistance is I2, R2, I2, R2, I2, R2, I2, R2. Okay, now we'll go here up. No, nothing is there, component is not there. Here the electrical component, electrical element or component is not there, so we'll move to the other resistor here. So here we can see the path, circular loop path is this direction. Current, we can see here the negative terminal is there. Negative terminal means current may be coming from this side to come to the lower potential, higher potential to the lower potential. So higher potential, this one. So current is coming from in this direction, means both are in same direction. If both are in same direction, negative. Negative means current is I1. I1 into R1. I1 into R1 is a potential difference. As we are considering both are in same direction, we are considering as a minus I1 R1. Again here the one battery is there, that is a cell is there. Again how the path here, minus to plus. Minus to plus means potential is increasing. If potential is increasing, plus V1 is equal to 0. This total, if we add the net charge, you will get the 0. Now in the same way you can consider this loop and whole loop also you can consider. Now here one small example is there, we will wrap up with this last example. Okay, so here what is he is asking to find out the potential difference. He is asking find the current, how much current is flowing if we are placing a battery of 12 volts, means if we are giving 12 volts of potential difference, how much current we can draw. If we are giving 12 volts of potential difference, how much current we will get. Let's see how much. First we will understand the circuit diagram, means how the current path will be in this circuit. We will understand that. Okay, so here positive terminal, this is positive. By seeing this we can understand now the long here the long line represents a positive terminal and the short one is negative terminal. This current starts flowing from here. Okay, so positive terminal means current is coming from this side. Okay, current is coming from this side. Okay, I here. Okay, I current is flowing from this direction. Okay, suppose here I is there, so I start positive terminal, here it is current is flowing. Okay, current is flowing here. What is happening here? 12 volts. I here starting here. So what is happening here? I means here what is here? Junction is there. Here junction is there, means some current might be flowing in this direction and some current might be flowing in this direction. So the current here this side moving current is flowing, current is I, and this side current flowing is I1, because here junction is there, means the direction of the current, this direction is I, this direction is I1. So what happens here? The current I1, it will flow from this direction, again it will flow in this direction, again in this direction. Again what happens here? I1 current is flowing here, na? Here I1 current will come and it will stop here. Okay, I1 current will come and stop here. Again from here what happens? I current will flow. Is it clear video? Okay, here the current I will come here and from this direction again the current will flow, again the current will I will flow, again it will come here. Means here what is happening? Current I and from this direction I1, both are what's happening? I1 plus I2, both are joining together, I1 plus I2. Again it's coming from the junction D, this is another junction, from the junction D, again it is coming here, again it's coming again here, from here I1 plus I2, again I1, means from here junction I1 plus I2 it's entering here, from this junction it is divided into I1 and I and I1, I and I1 here it's dividing, here I1 plus I1 here it is joining. Okay, from this junction I1 from this junction I plus I1 it's entering, from this junction I plus I1 is leaving, means current entering here, current leaving here. Okay, now we'll understand here. Only one loop I will explain. Okay, DAFED. Okay, DAFED, DAFED. Okay, starting point, ending point, one loop. Okay, one loop. So we'll first consider the clockwise or anti-clockwise. See, clockwise direction or anti-clockwise direction from this here, clockwise direction. Okay, see here like this. Okay, we'll consider the loop direction. Okay, see here D to A. D to A means how many? First we'll consider how many resistors are there. Two resistors are there, one battery is there. Two resistors are there, and one cell is there. Okay, two resistors means see here the current is flowing and the path direction I am taking here. The path direction in here, this one. Again we'll consider here one more direction, again here, again here, again here, again it will come. Okay, now we'll consider the current direction. Okay, current direction path is from here na, E to D, D to A, D to A. Okay, D to A is coming, current is flowing from in this direction. So here the current is how much here, I1. Here we can consider it as a current is as a I1. Okay, so what we will write here, I1 means what, here 3, what how we will write the potential difference, IR1. R is how much here, 3 ohms. R is how much here, 3 ohms. So means 1 I into 3, 3 into 1, 3 into 1 is 3 I1. Okay, current is I1, resistance is 3. Means what will write, I1 into 3. I1 into 3 is 3 I1. 3 I1. See here the current direction and the circular loop direction and the current direction both are in same direction. If both are in same direction, what will take? Will take minus. So minus 3I. Okay. If the loop direction and the current direction, if both are in same direction, then we'll take minus 3I. Next we'll come to 12 volts. 12 volts, see here, minus to plus. Minus to plus means increasing. Increasing means 12 will write. Okay. Again what we'll write here, will come this side, nothing is there, we'll go this side. Okay. So what is happening here, current direction is this direction and the loop direction is also same direction. Okay, current direction and the loop direction both are in same direction. If both are in same direction, what we'll write? We'll write it as a minus. We'll write it here. What is the current here flowing? I current. Here I current is flowing, means V is equal to IR. I is equal to I only, R is 4. So what we will write, 4I. 4I we will write, but both circular loop path direction as well as a current direction both are in same direction. We will write it as a minus 4I. Okay, is equal to 0 we will write. Okay, again we will consider the next loop path we will consider. Okay, here what we will write here, minus 3I minus 4I will write. Okay, if we equate this one, 4I will come this side, 3I will come this side, is equal to 2. Means minus 3I is equal to minus 4I is equal to minus 12 will get. Okay, so I will remove this minus 3I plus 4I is equal to minus 12. Minus will get cancelled. 3I plus 4I is equal to 12. 3I1 plus 4I is equal to, will get this much. Okay, the same way we will consider this loop also. Okay, we will get the equation here. These two equations will get it here. Okay, this equation we got from this loop, this equation we got from this loop. Again what happens here, this will be the equation here. We will get this one equation. What will get, 4I plus 3I1, 4I plus 3I1 is equal to 12 we will get. Okay, so what will write, 2I minus 5I1 is equal to minus 7. Here minus is there, I want to remove this minus. So I will multiply both the sides with minus. Okay, minus, if you will remove, what happens here, I will remove the minus. I will multiply with minus and I will remove the minus. And you know how to equate. This is first equation, this is second equation. Equate these two equation. Okay, so I will multiply first equation with 2, second equation by 4. What happens here, 2 into 4, 8I plus 6I1 plus 24. Okay, so here by equating, I'll remove this minus symbol. So what I will get, 8I plus 6I1 is equal to 24, minus 8I1, 20I1, 28 means this one will get cancelled. 20 plus 6, 26, I1 is equal to 52. I1 is equal to 52 by 26 ones are 26, means I1 how much I got, 2 amperes, 2 amp means current is 2 ampere. Potential difference how much is given, V is equal to 12 volts, means if we give the potential difference of 12 volts, we will get the current as 2 amps, means for 12 potential difference current will be 2 amps will get. Okay, this is what it's explained here. Here means here in bulbs it will be written at the back of the bulb. If you can see, just hold a bulb, If you want to see, you can see it by taking a 60-watt bulbs in 220 watt. Okay, if we give the 220 watts, means input, if the potential difference is 220 watts, we will get 60 watts of current. Okay, means if the potential difference is 220 watts, if the potential difference is 220 watts, the power we'll get is as a 60 watts. Okay, that's it. I think everything is clear here. Okay, let's meet in another video. In next video we'll start electric power. Okay, one more interesting topic, that is the electric power. By this, after electric power, I think the chapter will be, I think one more topic is there, electric power. Okay, and few application based questions are there. With this, we'll wrap up the chapter. Okay, right. Thank you, everyone.